Okay, so Unit 4, Objective 1, we were looking at simplifying and then multiplying and dividing rational expressions. Okay, so you should have all of this on your notes. You're more than welcome to take a read through it. I would especially draw your attention to this box here, which states that x minus y and y minus x are opposite, so therefore they can be simplified by factoring a negative 1 out. So you do want to make sure you keep an eye out for that. Okay. So we're going to walk through a handful of these just to kind of demonstrate the simplification process. So we're going to start here actually with number 2. To simplify, you're going to start with factoring your numerator and denominator as completely as you are able to using any of these procedures. Okay, so for this guy, it means I'm on my numerator, I'm going to factor out a 2x, which would leave me with x squared minus 4. On the bottom, we have a difference of 2 squared, so x minus 2x plus 2. And then factoring the numerator again, we'd have x minus 2x plus 2 for that difference of 2 squareds there over x minus 2 times x plus 2 in my denominator. Okay, so we factored completely. Step 2, you are then going to identify any of your excluded values. Excluded values are anything that would make the denominator equal 0, and you do want to consider your original denominator here. You also then want to pay attention to any, we'll call them new denominators as you go. Every once in a while you will find something that maybe didn't initially look like a denominator in the problem, but as you kind of work through the problem it will end up in the denominator, and if that happens you do need to consider that value as an excluded value as well. So again, excluded value is anything that would make the denominator equal 0. So in this case we have 2 pieces to our denominator. To make these equal 0, x would be either 2 or negative 2. And so both of those are excluded values, and we will put those in our answer. Last step, we are going to reduce. X minus 2's will reduce, x plus 2's will reduce, and so my answer is 2x. And like I said, we have our 2 excluded values. X cannot equal 2 or negative 2 from my denominator here. Okay? Okay, so my recommendation, we're going to do number 3 next. Go ahead and pause the video, give number 3 a shot, restart it when you either are ready with an answer or are stuck, whichever one comes first. Okay, number 3, factoring. This is a cubic factor here. Now one thing we could do is factor a negative out at the beginning. That would turn it into our kind of traditional cubic factor form. You don't have to do that, but it's an idea. Down here, this is a trinomial that factors to w minus 4 times w minus 4. In the numerator again then, we have our cubics, so our w, and then we keep the sign the same, and 4. W squared, our sign is now opposite. A times b, which would be 4w, and then always positive, our 4 squared. That soap idea. Okay. So now that we've completely factored, we're going to consider what are my excluded values. In this case, I have 2 things in the denominator. For those to equal 0, it'd actually be 4 in both instances, so we only have 1 excluded value of 4. And then simplifying, the w minus 4's would go away, and we'd be left with our negative, our w squared plus 4w plus 16 over our w minus 4 with that excluded value of 4. Okay, one more here in this form, number 4. Go ahead and pause the video if you haven't already on number 3, but do so on number 4. Pause the video. Work through it, give it a shot, and restart the video when either you are stuck or have an answer. Okay, number 4. We are doing f divided by g, so my 3 minus 3y divided by my g, 2y squared minus 2. Okay. And so then factoring this, a 3 comes out on top, and actually I'm going to go ahead and pull out a negative 3. And so this negative 3y would become positive y, and this positive 3 would become negative 1 when I factored a negative 3 out. Down here, pulling out a 2, we have y squared minus 1, which is a difference of 2 squareds. We are looking at negative 3 times y minus 1 over y minus 1, y plus 1, and our 2 out front. Okay, excluded values. I have 3 things in the denominator. Well, 2 won't ever equal 0. It's 2. Y minus 1 would equal 0 at 1. Y plus 1 would equal 0 at negative 1. So we have 2 excluded values. Simplifying, we have negative 3 over 2 times y plus 1 with excluded values, therefore, at negative 1 and positive 1. Okay, so that's simplifying. And then we did 2 extension pieces to our simplifications in 5 and 6. And then 6 actually applies also a little bit to number 11. So we're going to walk through number 5 here, and then I'm going to hold off on number 6. I'll come back to it when we hit number 11 on the back side, because like I said, there's a connection between the two. Okay? In number 5 here, we are again simplifying, so we need to start with factoring. We did number 5 because it's kind of a weirder factor. In the numerator here, there is a GCF that factors out. We have our first term here. Should I grab a highlighter really quickly? We have our first term here at 6x plus 5 quantity cubed times 8x. And we have a second term here of 4x squared times 3 times 6x plus 5 quantity squared times 6. And those 2 terms have a couple of things in common. First of all, they both have a 6x plus 5 quantity squared. And so I could pull that out, 6x plus 5 quantity squared. Okay. They also have a 4x in common. Okay. 8x has a 4x and 4x squared has a 4x. Technically speaking, for the record, they also have an additional 2 in common. I will say that's usually harder for people to see at this step. If you can see already that there's an additional 2 in common, you could pull that out as well, but I'm going to go ahead and just pull out the 4x at this point, and that will work out just fine. You'll see as we go through. Okay, so pulling those 2 pieces out, the question is then what am I left with? Well, in this first term, if I pulled out a 4x, I'd be left with 2. And if I pulled out 2 6x plus 5s, I'd be left with 1 additional 6x plus 5. So the 2 and the 6x plus 5. Back here, if I pulled out the 4x and the 2 6x plus 5s, I'd be left with an x, a 3, and a 6, which makes 18. Well, what that allows us to do is to simplify. Right? There are 2 6x plus 5s here that'll cross off. There are 6 down here, so that will make 4. And so I'd be left with 4x. Here we would have our, kind of simplifying this would be 12x minus 18x, which is negative 6x, and 10. And it's at this point where if you didn't see that 2 that we mentioned at the beginning is technically in common, if you didn't see that 2, you could pull a 2 out at this point. Okay. We only have the 1 excluded value, so I'm going to go ahead, actually I'm going to pull out a negative 2, just to flip this negative 6x to be positive. So we'd have positive 3x and minus 5, pulling out a negative 2 with the 4x. So what I was saying is we actually only have 1 excluded value for this function. It would be that x cannot equal, what would make the denominator here equal 0? That would be negative 5/6. Okay. Okay, so we did a couple more of these in class after this point. We will continue to practice these. So this is the only one that's in the notes, but it is one we need to kind of make sure we've mastered. So if the one is not enough, if you were absent and need more, please remind me in class. We will do more practice, but this is the only one we did here, specifically in the notes packet. Like I said, we moved to whiteboards after this. Okay? Okay, so again, I'm going to come back to number 6 when we do number 11. Let's go ahead and turn the page here to our multiplying and dividing. We again are going to do 3 of these, like we did 3 on the front. Okay, multiplying and dividing, you're going to start with, again, factoring your numerator and denominator as much as you can. And then you're going to rewrite as a single fraction, remembering that when you divide by a fraction, it actually means you multiply by its reciprocal. This is what a lot of kind of your teachers in the past maybe referred to as keep, change, flip, that idea of keeping the first term the same, changing the sign from division to multiplication, and then flipping your second term. It's that same idea here with our polynomial expressions. Okay? So step 1, factor. We have a cubic factor up here, so this is x minus 2, and then x squared, opposite sign, so plus 2x, and then always positive. Down here we have a difference of 2 squareds, and I'm actually going to pull out the negative as I do that difference of 2 squareds, so this will become negative x squared minus 4. So negative x minus 2 times x plus 2. And then we have times trinomial factoring, x plus 2, x plus 3. And GCF factor out an x, we're left with x times x plus 3. Okay? Excluded values, looking at our denominator here, nothing will make negative equal 0, but 2, negative 2, 0, and negative 3 are all excluded values. And so you want to look and make sure you identify those. And you want to do that before you flip this fraction if this was a division. Because this is a denominator. And so even if this was a division and we were going to spin this fraction, you would need to still consider the excluded values there. However, it's not division, so we're good to go. Okay, so multiplying these together, the x minus 2's would cancel, my x plus 2's would cancel, my x plus 3's would cancel, and I'd be left with an x squared plus 2x plus 4 on top, and a negative x on bottom, with all those excluded values we identified at the beginning, 2, negative 2, 0, and negative 3. Okay, so we're going to do 2 more. Again, if at any point you feel like you are ready, I would highly recommend, maybe even on this one, pausing the video, seeing how far you can get on your own, restarting it when either you are stuck or have an answer. But I would do that with either 8 and 9, or at least with 9, because watching me kind of work through it is only so beneficial. You need to make sure that you are actually practicing it on your own. Okay, so this guy, factoring it, we have trinomial, so y plus 2 times y plus 4, and trinomial, y plus 2 and y minus 1, divided by, y plus 4 is already factored, and a GCF here, 2 times y plus 4, I'm sorry, y plus 2. Okay. And so you would want to pause. Yes, we are going to keep change flip here because of that division, but take note that negative 2 is an excluded value for this function. So we need to make sure that negative 2 does end up being in my answer as an excluded value. Okay, so let's go ahead and keep change flip. So keep y plus 2, y plus 4 over y plus 2, y minus 1. Change to multiplication and multiply by the reciprocal. We have 2 times y plus 2 over y plus 4. And again, I'm not losing sight of this negative 2. That was an excluded value originally. I then have three other excluded values, -4, 1, and, oh look, -2 again. So we kind of luck out in this case, right? Because the -2 was going to be there anyway. It would have been okay if you had missed it, but that's not going to be true for every function. So make sure you are very, very careful with that particular denominator, the one that switches to be in the numerator. It is an excluded value. We just kind of luck out in this case that we have it in the other fraction as well. Okay, simplifying, the y plus 2's cancel, the y plus 4's cancel, and so I'm left with 2 and y plus 2 over y minus 1 with excluded values of -2, 1, -4, and then originally -2, but I already had that, so I'm good to go. Okay. Okay, so one more. If you haven't already, pause the video, give it a shot on your own, restart it when you are ready. Okay, factoring, we have y plus 4 over down here. It's y plus 2 times y plus 3 divided by 3y is a GCF that's getting pulled out, leaving me with y plus 4. And here we have 2y minus 1 times y plus 3. Okay, so two excluded values here that I need to make sure I take note of. We have 1/2 and -3, as well as these two over here. But the reason I'm drawing our attention to these two is because now we're going to keep, change, flip, and those are going to move out of the denominator, which means it's easy to miss them as excluded values. You need to be careful. Okay, keep, and then multiply by the reciprocal. Change, flip. Okay, which gives me, in addition to the 1/2 and the -3 that I already identified, we now have -4, 0, -3 again, and -2. Okay, simplifying, y plus 4's will cancel, y plus 3's will cancel, which will leave me with 2y minus 1 over 3y times y plus 2. 0, -2, -3, -4, and 1/2. All those excluded values that I identified from my denominators equaling 0. Okay. Okay, two more problems that have a very similar simplification step, so 11 and then 6. Okay, 11 and 6, both of them we run into an issue, which is that we have a complex fraction here. A fraction inside of another fraction. And so it's a strategy you can use to easily get rid of those denominators. The strategy is to multiply the top by its denominator. And in multiplying by that y, I also have to multiply the bottom by y to maintain equality. And then look at your denominator and go, okay, well, what is the denominator's extra denominator? Because I'll multiply by it as well. Well, the denominator's denominator is y. Well, what do you know? I'm already multiplying by y. So I'm good to go. If this one had, say, been x, well, then I would have multiplied by x and then multiplied an x to the top as well. You have to maintain equality. Multiplying by y over y means that I'm technically multiplying by 1. And think about what that does to your function. Multiplying by 1 does absolutely nothing at all. And so I'm safe as long as I multiply top and bottom by the same value. Okay? So, distributing this yn, the y's would cancel, leaving me with x, and then distributing the yn, we'd have 3y. In the bottom here, distributing the yn, the y's would cancel, leaving me with x squared, and distributing the y minus 9y squared, which is a difference of two squareds. We have x plus 3y over x plus 3y times x minus 3y. Two excluded values here. X cannot equal -3y, and x cannot equal positive 3y. Because if x was positive 3y, that would be 0. If x was negative 3y, that would be 0. And so then simplifying, we have 1 over x minus 3y with 2 excluded values. X cannot equal either positive or negative 3y. Okay. Okay, so one more in this form. Going back to number 6. Okay, this one also has an extra denominator. Its extra denominator is right here with the negative exponent. What does a negative exponent do? It moves within a fraction, right? The fact that we have a negative exponent tells me that that x to the 1/3 actually is down here in the denominator below the 4. And then we have our all over, I'm going to factor that 2 out, 2 times x minus 4. Okay, so using the strategy we just looked at, let's go ahead and multiply by our extra denominators. In the numerator here, that means I'm multiplying by x to the 1/3, which means I have to do that x to the 1/3 in the bottom as well. In the denominator, I have no extra denominators, so I'm good to go. Okay, distributing this x to the 1/3 in, x to the 2/3 times x to the 1/3. When you multiply like bases, you add their exponents. So this would be x to the 2/3 plus 1/3, which is 1. And then distributing the x to the 1/3 in, they would cancel, leaving me with just minus 4. Down here, these are all being multiplied together, so I'm just going to write them side by side. Okay. Excluded values. X cannot equal 0. X cannot equal positive 4. And so then simplifying, we have 1 over 2x to the 1/3, where x cannot equal either 0 or 4. Okay. Okay, the two we skipped were ones that were just reviewing our exponent rules. So number 1, okay, if you wanted to really quickly pause the video and work through number 1, I will give an explanation on number 1, or I will give an answer. It's just to review your exponent rules. So go ahead and pause it, give number 1 a shot if you'd like. Okay, 21 and 7 would simplify, leaving me with just 3. A squared over a cubed would simplify, leaving me with just a. And b over b to the 4th would simplify. A would simplify to leave me with b cubed in the bottom. Okay, and actually I do have excluded values here as well. A and b, neither of them can equal 0, or else my denominator would equal 0. So you could still list excluded values there as well. Okay. And then number 10, again, just to give you some kind of practice with exponent rules. Again, if you want to pause it, go ahead and do so. Okay, here my 3 and my 6 would cross simplify, giving me 2. My x squareds would cross off. My x's would cross off. My y's would cross off. And what would I be left with? I'd be left with a 2 on top and a y squared on bottom. With, again, I can identify excluded values here. Neither x nor y can equal 0. Okay, so those are some, like I said, older exponent rules out of kind of Honors Math 8/Math 1 in that vicinity of your mathematical experience. And so it's good just to remember them. Okay, there you go.